Michele.
Vielen Dank. So, welcome to this talk. The title of the talk is deicIDE. What is a deicIDE? A deicIDE is the killing of a god. Now, you have to understand, I have a knack for dramatic presentations, okay? This is actually my 4th keynote. The first one was entitled The Visual Terminator. The second one was Requiem for Software Engineering. The third one was Metamorphosis. And the 4th one is deicIDE. The whole presentation follows a little bit the theme of a game series I appreciate quite a lot called God of War, okay? I have been a gamer for the last 29 years, okay? And it's structured in 3 parts. There's the inception, an ascension, and the transcendence. So I'm here essentially to kill a god. But the question is, who am I? Who is the killer, okay? Well, I come from a country that is located here. It's known to you probably as Absurdistan. But as a matter of fact, right now, I live in another country called Bankistan. And in Lugano, I built, when I went there 10 years ago, my own research group. The research group is called Reveal. So whatever I'm showing to you today is, of course, not only the product of my own work, but it's built on the work of several PhD students throughout the last 10 years, okay? With respect to my keynote, there's 3 points I'd like to make up front. The first one is that this is really my own personal opinion, okay? So you don't have to agree with it. As a matter of fact, I would actually prefer if you would not agree with it. The second one is that even if you disagree, throughout the talk, I will point out a number of books, beautiful books, that I really recommend you to read, okay? So even if you disagree, if you just pick up one of those books, I will have succeeded. And the third thing is that in general, I am a believer of tools and Tool. Tool is, among others, also my favorite band, in case anyone knows it. But here we go, Inception. Let's start. I'd like to start with a car, okay? I know Germans don't know a lot about car building. But believe me, this is a beautiful car, okay? It's a Ferrari P330. But it's not about this car I want to talk. I want to talk about this car here. This is the Bugatti Veyron 16.4. It has close to 1,000 brake horsepower, and when it came out in 2006, it was the world's fastest production car, 408 kilometers per hour. 1 year later, the Americans made this car here, the Shelby Supercars Ultimate Aero TT. Yeah, I know they have ugly names. And it was slightly faster, okay? Of course, Bugatti couldn't let it sit on them, so they made another one, the Bugatti Veyron Supersport. This has close to 1,200 brake horsepower and went at 431 kilometers per hour. Now, if you look at the difference between the first Bugatti and the second Bugatti, the difference is essentially this, okay? A Volkswagen GTI. It's exactly the difference in brake horsepower, and the Volkswagen GTI, this is a Volkswagen 5, I used to have this car, goes at 235 kilometers. Believe me, it's true, I tried it. Now, the thing is, you take a car which is really fast, you add on top of it the power of also a fast car, but what you get is actually only a minor increase in speed. How come? And this is actually the whole point I'm trying to make during this presentation, that if the god of software engineering, known as integrated development environment, keeps evolving like it has done the last 40 years, we will never go much faster. Now, what is an integrated development environment? Essentially, it does this. It's an environment to edit, compile, and run source code. I guess nothing new here. And probably, in my memory, one of the nicest environments who could ever embody that notion of editing, compiling, and running source code was this one here. This is Turbo Pascal from the 90s, a splendid environment, okay? As a matter of fact, while IDEs were being developed, so this is from the 90s, there's another thing, text editors, okay? And there's two major competitors that have been evolved over the last 40 years or so. They are known as VI and emacs. Now, I would like to draw your attention on the face of VI users and the face of emacs users. Now, still, these text editors are incredibly powerful, okay? So I also used VI, I also used emacs. Nobody's innocent in this room. And they represented a huge leap forward from this, okay? This is the way that people used to enter source code into machines. Funnily enough, there has been a parallel track that has been completely ignored, I think, by software industry. If you look at this environment here, this is the Smalltalk environment. This was done 40 years ago. 40 years ago, it looked like that, okay? Now, you take a time machine, you jump into the time machine, you move forward 40 years, and what do you have? Do you have space cities with things flying around? No, you have that, okay? So something must have gone wrong during this 40 years. And I believe it's time for new IDEs and also new ideas. Because if programming is comparable to surgery, right now I think that we are doing surgery with these utensils here. So essentially, the IDE must die, okay? And to do so, I'd like to press a reset button and ask you, what is software? What is really software? I guess that you have been working for years with this thing called software, but if you would have to answer this question to your grandmom or your grandpa, you would probably have problems doing so. I once tried it with my grandpa, and in the end he looked at me and said, oh, it's like cartoons. I'm like, okay, and I gave up. So I'll take the simplest definition that I can get, and that's of course from Wikipedia. Software is a collection of computer programs and data that provides the instructions to tell a computer what to do and how to do it. And very important, in contrast to hardware, software cannot be touched. You can't touch it, right? Another thing is software is written, okay? This is the general notion. This was already coined by Weinberg more than 40 years ago in a beautiful book called Psychology of Computer Programming. And there he says that programming is a kind of writing. And I guess that most of you don't really disagree with that. But if programming is writing, what follows is that software is text, right? And I guess that most of you don't disagree with that. You look at something like this. This is the world's smallest chess program, okay? It's 133 lines of C code. You can compile it, and it runs. An astounding feat of programming. The guy who has done this has really thick balls. Or you look at something like this. This is from the obfuscated C contest. This is also a compilable piece of code. And you look at this and go like, wow, the guys who do that, they are really tough guys, okay? But, let's think about it. If we go from the lowest level to the highest level of abstraction in a system, starting with lines and then with bodies and then with signatures and then with class descriptions, let's say, with packages, subsystems, namespaces, and finally we end up at the system level. So far, if you look at common IDEs, the writing is all over the place. You always write. But in reality, I think that writing only goes to a certain level, and then it stops being writing, and it starts being something like constructing. You actually construct, you create software systems. Now, I don't want to drag on too long regarding your curiosity, and I will answer the question, what is the ideal IDE right away? Now, I could answer something like this, okay? This is Code Bubbles, in case you've seen it once. Very nice, okay? It's built on top of Eclipse. This is Code Canvas by Microsoft Research, also very, very nice. And along these lines, as a matter of fact, a couple of months before they did that, we in Lugano also did something like this called Gaucho. But to me, these things, although they are conceptually nice, they lack something. So if you ask me what is the ideal IDE looks like this, okay? It's just a blank surface where you create things. And I can cite here Fred Brooks, who wrote in his book, The Mythical Man Month, that programmers are like poets, okay? That you build something out of nothing. This is pure creation, okay? This is why programmers are pretty much the coolest people on this planet, okay? But if you look at things like code bubbles or different extensions to the Eclipse IDE, coming back to cars, this reminds me a little bit of this, okay? You just keep adding spoilers on top of your car, trying to make it a little bit faster. But what is really needed is something else, like a different metaphor, okay? This, by the way, is the world's fastest Earth-traveling vehicle right now. So let's try to go beyond that. Let's try to ascend. I deeply believe in a discipline called software visualization, which is built on a discipline called information visualization. Colin Ware in his book says that we acquire more information through vision than through all the other senses combined. Around 70% of the sensorial input that we have comes through the eyes. I hope you also know that we don't see with the eyes. As a matter of fact, we see with the brain, because the eyes are just cameras. And then in the back of our head, something else happens. But I guess that you all know all that. But software visualization, what is that? Well, first let me tell you what it's not, okay? So I need to dispel a couple of myths around it. The first one is that a picture is worth 1,000 words. This is a sentence you hear when people try to motivate visual approaches. This is wrong, okay? Because if the picture sucks, then you cannot really say anything with it. The other thing is that UML is software visualization. Well, this is also wrong, because UML is not software visualization. UML is a visual language to describe the design of software systems, okay? And from a purely cognitive point of view, UML is horrible, okay? It's because the people who created UML had no clue about how to create a visual language. But it's too easy to bash UML, because UML still is a de facto standard, and you can give a UML diagram to someone in Brazil or someone in India, and they will still understand it. So it's a great thing. But it's not software visualization. The third thing is that visual programming is software visualization, and this is also wrong. What you see here in the 90s, visual programming languages became popular. This is the implementation of factorial, okay? This all boxes and stuff like this. I'm sorry to say, but if you take a language like Scheme, you can write factorial as a one-liner, okay? So you don't need all this stuff. And another thing which is wrong is that people who do software visualization often think of it in terms of static visualization, so you visualize the information you can get at compile time, and dynamic visualization, the information you can get at runtime. This is completely wrong, okay? Because if it's a very categorical subdivision, and if you would do something like this, then probably this is a good description of a human being, okay? We are water, meat, and bones, most of all. I prefer to think of it in terms of visualizations about software, where you try to visualize facts about the system. And much more interesting to me is visualization of software, where I actually try to visualize the software itself. But let's set the context first. Software visualization is a subdiscipline of information visualization. And there I would like to point to two people that probably you have never heard of in your life, but they probably had an impact on your life. The first one is this guy here. His name is William Playfair. Lived 250 years ago. He was a merchant from England. And this guy alone created the bar chart, the line chart, and on a bad day, he even created the pie chart, okay? And the other guy that you have to know is Jacques Bertin, a French guy. Around 50 years ago, he wrote a book called The Semiology of Graphics, a fantastic book. And whatever Playfair didn't do, Bertin did, okay? These two guys have done everything there is to do about the visual display of quantitative information. In this context, I can point you to two books if you're interested. One is by Stephen Few called Show Me the Numbers. The other one is by Tufte, The Eternal Tufte. Very nice books, okay? I can really recommend them. But what is the point of a visualization? The point of visualization is that you can tell a story with the information that you display. And I'll give you just one example of how you can tell a story with a visualization. Who has ever seen this? Okay, at least a couple. This, in my opinion, is the most beautiful information visualization ever done. It depicts the campaign, the Russian campaign of Napoleon. So we are in the year 1813. We are here somewhere in Poland. Paris is somewhere over here. And Moscow is over there. What you see here is the army of Napoleon. The width of the band represents the size of the army. And here, it's written here, it's 442,000 soldiers, close to 500,000 soldiers. And as they march east, because they were marching, okay, there were no cars back then, and few people had a horse, the band gets thinner and thinner. Only 100,000 people arrive in Moscow. Why did so many die? Well, first of all, because this from here to here, it's around 2,000 kilometers. Second, and this is the part that you see down here, it was incredibly cold. This winter was one of the coldest registered winters ever. This is an old temperature scale in Reaumur, which doesn't exist anymore, but just imagine that the line here on top is 0 degrees Celsius. So it was always below freezing point. Here it was around 30, 35 degrees below Celsius, okay, and the people had to march. That's why when they arrived here, the army was already decimated, and since 100,000 people were not enough to conquer Moscow, what they did is set fire to the city and run. And this is the second part here. Here they ran away, and at the very end, what is here, only 10,000 people make it back. So 500,000 people have died during this campaign for nothing, essentially. But the amazing thing are the details. For example, look at this one here. I'll make it larger for you. This is a river called Berezina. You have here 50,000 soldiers arrive, and then only 28,000 make it over the bridge. This happened in a matter of a couple of hours. What happened there? This is a report from the aide de camp of Napoleon, so basically the right hand. He says that when they arrived to the bridge was very narrow. The Russians were in their back chasing them. So what did they do? They started to kill each other to make it over the bridge, okay? And when Napoleon had to go through, they just cut away through the people. There's also, legend also says that they built actually a second bridge with the bodies of the dead people and then marched over those bodies. Now, isn't this a fantastic story? You could make a movie out of that, okay? So this is the point of visualization. But now the question is coming back to software. How can you make a story about software? Because there's a problem here. I used to call this Ball's dilemma. They said that software is intangible because it has no physical shape or size. So how can you visualize something if it doesn't have a shape to start from? Well, there's one workaround, and that is metaphors. Humans are good at metaphors. So I was inspired by a book, a very nice book I read around 15 years ago by Dick Gabriel, and he talks there about the habitability of software systems. This is the thing that makes you be at ease in a software system. Like, it's nice to be here. Then you go to another system as a programmer, and you say, oh, it sucks to be here, okay? The system is ugly. And I guess that the developers in this room know what I'm talking about, that sometimes there are nice systems and there's ugly systems. Taking this concept and pushing it a little bit further, I ended up with the metaphor of software cities. Let's try to visualize software systems as cities, okay? It took me a couple of years until I could find a good PhD student, but in the end I found him. His name is Richard Vettel, and he did a PhD for me in this context. An amazing programmer. Now, how does this work? The city metaphor. Essentially, you display packages as districts of a city, okay? And then you display the classes in the system as buildings. And then you map software metrics on top of the buildings. For example, for the height, you map the number of methods. And for the width and the length, in this case, we map the number of attributes, okay? And on the color, we can map, for example, lines of code. So lots of combinations which are possible. And then you do this, you take it on a larger system, and that's the way it looks, okay? So this is Argo UML, around from 6 years ago, I would say. So there it was around 140,000 lines of actual source code. And what this allows you to do is program comprehension, because patterns start to emerge. For example, you see these things here. There are like office buildings, so lots of functionality, lots of behavior. Often close to the office buildings, you have the parking lots. Parking lots are classes with very reduced functionality, essentially no functionality, no methods, but lots of attributes. That's why they are so wide. Then you have, for example, little suburbs here where the people live with a car and a dog and the 2 kids. Here you have these antenna-shaped buildings. These are the interfaces, okay? No state, lots of functionality. So this is what this allows you to do. I'll just now give you a round trip for a bunch of software systems visualized with this metaphor. Let's start. This is ScumVM, that's a game engine in C++. As you see, 300,000 lines of code. And you will see also that depending on the programming language, the cities look a little bit different. This is Code City, our tool to visualize those systems, written in Smalltalk, of course. So you see again, Smalltalk, very airy, very light, best language ever. This is iText that's a C# system. And funnily enough, iText was also written in Java, and here you have the Java version. You see, similar, right? Because it's a similar system, but the language has some impact. Then you have JMOL, and now we go larger. You have JEdit, 100,000 lines of code, ArgoUML, 140,000, GWT, 200,000, JBoss, 400,000, JDK, 1 million lines of code, and finally Eclipse itself, 3 million lines of actual code, 28,000 classes, a gigantic system. I know it looks small here. If you put things in a perspective, that's the way they actually look, okay? So Eclipse is very, very large, okay? What this also allows you to do is to spot problems right away. This, for example, is OpenSwing. But you should notice here that the system is not trivial at all because it has close to 2,000 classes, okay? And more than 100,000 lines of code. It's just that one class in the system is a little bit too large compared to the other ones. Okay, what can you do otherwise with this? Well, you can visualize software evolution. Simplest thing you can do is we take snapshots, okay? So here you see, for example, the evolution of ArgoUML over 5 years, in 9 versions. Here, for example, you see a problem showing up. It's a class called Model Facade, became gigantic in 2004, and was then refactored into an interface, and the class implementing the interface. You can map age information on this. The lighter, the younger. So what do you see here? For example, there's an office building here called Java Recognizer. ArgoUML exports and imports Java code. And Java token types, which is the data types that you need. Funnily enough, in the same system, you have, again, Java Recognizer and, again, Java token type. But that's the problem that these guys have. And here, for example, you see CPP parser, that's for C++, and STDC token type. So from this, you can, for example, infer that ArgoUML first supported Java and later on supported C++. You can also go finer-grained. Finer-grained looks like this. Essentially, you map a class as a platform, and then you stack all the methods on top of it. If methods are removed during the evolution, this results in a whole. And this might look funky to you or nice, but as a matter of fact, this class, for example, is a problem. Because at each evolution or each version, someone had to go and do something about it, which essentially means money was spent on this. So this then leads to a pattern language of itself that I'm not going to go into. Other things you can do is to do a little time traveling. For example, this is again ArgoUML, and here you see how things evolve over time, right? So Model Facade at one moment becomes gigantic and then disappears. And you can also do the same with the fine-grained one. This is now JHotDraw. I guess most people here know JHotDraw from somewhere. So here you see that the system gets older, and they work on it. They remove some stuff. They add some more stuff. And then they add some more stuff. And then at one moment, this happens. Of course, these are 6 months time intervals, but we shrank it down to actually 1 day. So they did all that in 1 day. How the heck can they do so much coding in 1 day? So we talked to the developers, and in the end, I should mention, this is the test package, okay? So it's not test-driven development here. So what did they do? All that stuff is generated. They generated test methods which are empty. And then, after that, they started to fill them in slowly. Another thing you can do is to actually create a movie. This is a movie of 7 years of evolution of a system called JMOL. So at the beginning, as you see, not a lot happens. The system is growing nicely. These are the external APIs here. This is the actual system. So things grow and shrink or moved around a little bit. And then there is, I think, a minor refactoring in the system now. Then things start to grow. An office building pops up. A parking lot pops up. And then what happens is a re-architecting of the whole system, which happens now. And then they start to copy things over now. And now you have to see that the system at one moment explodes in size, and that will happen now. Okay? Now you can imagine that if you grow a system so quickly, that this might have some problems, right? This might generate some problems. Another thing you can do is to visualize design problems. I'm not going to go too much into. Here's just a prop about the book I've written with Radu Marinescu. But the metaphor here is health maps. So this, for example, in blue, you see the God classes in JDK 1.5. Here, for example, you see the methods of the model part of ArguML suffering from shotgun surgery. And here you see why, for example, you shouldn't attack the big monster here, because that's dangerous. But maybe you should attack something like this or something like that, because they are doable and they will have an immediate impact on the quality of the code. Remember the system in the movie before when it exploded in size? How can you quickly grow a system in size? Well, you just start abusing design rules. So you start reusing pieces all over the place. This leads to a problem called feature envy, right? Where the methods don't care anymore about the attributes in their own class. They start to care about the attributes in other classes and access them directly. And as you see, this is spread like cancer. Now, all of this is implemented in a tool called Code City. It's written in Smalltalk, but you can visualize pretty much any kind of software system. Okay? Because it's based on a platform and language-independent meta model. And we also did more stuff that we actually never published, like some funky ways to display information and so on. But I guess that in the meantime, you sit here and you go like, well, it might look nice, but is this useful? Is this actually useful, or is this just some academic BS? Okay? Now, a question, who is an academic in this room? Lift your hand. I am so sorry, guys. A quick interlude just for you on the chains of academia. You see what happened when we submitted the very first time this work to ICSE. ICSE is the conference on software engineering. Well, we got rejected, okay? And with what motivation? The reviewers said that they were not convinced they would learn anything from the visualizations. Now, I hope that in the meantime, you must have understood that you have seen lots of source code without actually looking at source code. You have seen complete evolution of cities without having to look at the actual code, okay? So I guess that in your mind, you must say, wait a second, this thing is useful for something, and this thing is weird. Now, my usual way of reacting to things like that is listening to Tool, and they say that if you knock me down, I'll just come back running. So what did we do? Well, in the name of science, we performed the largest scale experiment with human subjects ever done on this planet so far. Now, how does this work? Well, first, design, execution, and results of the experiment. The first, design. We did a state-of-the-art survey to understand how can you do an experiment with human subjects. And also, we had to learn that the state-of-the-art was essentially void, okay? But still, we deduced a list of design desiderata. I'm not going to go into all of them, but for example, you should avoid comparing a technique against not using the technique. You should involve participants from industry and not just a bunch of students. You should have more than one system. You should have a set of relevant tasks for the people, and so on. First thing we had to do is to find a baseline. So on the one hand, we have Code City, which is supposedly good, or we claim it's good for program comprehension, design quality assessment, and system evolution and analysis. What could a good baseline be? Well, Eclipse, right? Eclipse is one of the main vehicles for people to handle source code, to understand the source code and to modify the source code. So this is for program comprehension. Now, Eclipse is actually not good at design quality assessment. There's a bunch of plugins, but they're not stable, and so on. So in the end, we decided to give all the data that we had in the form of Excel tables. And what about system evolution analysis? Eclipse is also not good at that. So despite, I think, this being one of the very strong points of Code City, we had to abandon that, okay? So we are not going to go into this part regarding the experiment. This creates two research questions. The first one is, are you better with Code City at doing things? And the second one is, are you faster with Code City at doing things? So then we started to put together a set of tasks. I'm not going to go into this, but essentially 6 were for program comprehension, 4 were for design quality assessment, 9 were quantitative, 1 was qualitative, and then we executed the experiment. Experiments would always look like this. People would be trained for 1 hour with the use of Code City. I hope you understand that 1 hour is not enough, okay? But you can't ask much more from people. And then the experiment itself would last 2 hours. So you might wonder, why did you only have 10 tasks? Well, because you can't have people blocked for 3 days in a row. 2 hours is already on the limit. And then we rinsed and repeated all this. And the experiment was run, as a matter of fact, over 3 countries and in 4 different cities. In the end, we had 41 subjects who had gone through the experiment. They were equally divided between industry and academia, so they had different roles in industry and academia. They were of different ages, and they came from lots of different countries. We also actually, as a first-timer, put everything on the web. The questionnaires, the handouts, the solutions, the grading schemes, the data set, everything is available, okay? But I guess you are curious about the results now. What about the results? Well, with respect to the tasks that we had chosen for this experiment, the people with Code City were 24% faster than with Eclipse. No, better, actually, better. And they were 12% faster than with Eclipse. Now, I'm not here to talk about statistical significance and all that. The message here is essentially this one, that we kicked the crap out of Eclipse, okay? And all of this is statistically significant, so it's not by random chance. Now, of course, there's always the usual set of threats to validity and all that, but as a matter of fact, who cares, okay? Think about it. Even if we had been as good or as fast as Eclipse, the result would have been significant, because the tool that we have written in 3 years, 2 people, won against a tool that was written over the course of more than 10 years by thousands of people, backed up by a multi-billion-dollar industry, okay? So there is something there that I think is worth investigating. My personal opinion on this experiment, this is for the academics, is that the experiment essentially is a suicide, okay? It's an academic suicide to do such an experiment, because it took an incredible amount of time and energy to prove essentially what we knew from the start, okay? But if you are an academic and you are in the academic carousel, then you just have to go with it. Now, all of this in the end resulted in this, okay? An IDE paper. How cool is that? So now you could say, okay, now everybody is happy, okay? Now, is this the case? And this is something that really bugs me about academia. If you look at the paper from a distance, this is the paper, okay? So these are the 10 pages of a paper because it's limited to 10 pages. Do you know where the part is about Code City itself, where we present Code City? It's here, okay? This is the whole presentation of Code City. The rest is all experiment, okay? And I think that this is somehow completely missing the point, especially with respect to industrial people. Because if you go to a conference like ICSE, you would like to learn something about new things. And if you read our paper, there's 9.5 pages about how to run an experiment, okay? You know, academics in general, they have this fixation with impact. And the bad thing is that they measure impact with this, the number of citations, and this, the H index. And you know what this is? This is this, okay? Really. Because you can play this system easily by doing this, okay? So if I cite you and you cite me, we are both cited. How cool is that? Now, when it comes to impact, with respect to the work on Code City, I'm actually much happier about this. I know at least half a dozen companies who have in the meantime either used Code City for their own purposes or re-implemented it without saying thank you, okay, but that's something else, and they are making money with it. So it's cool. Now, Code City is written in Smalltalk. It's a standalone tool, so some of you might say, well, I would like to have something which is more usable right away. Just on a side notice, we also rewrote it for Eclipse in Java, and it looks like this. So here you have Eclipse, and then here you have the code city, and while you program here, this thing will change, okay? We actually integrated this also with the work of another PhD student of mine. Her name was Lile Hattori, which was about recording fine-grained changes. So while you program on the city and someone else is working also on the same system, you will see the changes in the city depicted as conflicts. For example, it will say, oh, well, watch it. Someone over there has done something now that will go in conflict with you. Out of academic honesty, I should also say that it's not the only piece of work in this direction. There's also work from University of Bern, which I find cool. There's actually also work from Germany, from Cottbus by Klaus Leverenz, which is also very nice. They also use a city metaphor in a slightly different way. By the way, I asked them to visualize Eclipse. So this is Eclipse in their view, and this is Eclipse in my view, okay? Now, I know that you might think that this is a bit too much, okay? It's too beyond, especially because I went further than this. This, by the way, is not Code City anymore. It's my own tool that I rewrote later on, because you can do things like that. This, for example, is the complete Smalltalk library. It's more than 8,000 classes. And you know what you realize when you do things like that? You realize that software is beautiful. Software is really beautiful. But I know that you might say, well, you can't take this seriously. But you see, the point of academic research is that it's a little bit like Formula One, okay? No, like this. Formula One, to the uninformed, looks like a bunch of overpaid drivers driving around in circles, burning a lot of fuel. But if you like Formula One, then you know that Formula One invented lots of stuff, okay? ABS, ceramic brakes, the turbo, CARES, aerodynamic technology, lots of stuff, okay? And then this trickled down into the reality of your own cars. And this is the way that I perceive academic research. It should go beyond, and maybe what you do is completely stupid. But if you don't go there, nobody will ever know. Now, does it stop here? Well, no, let's transcend a little bit. How do I perceive the future of integrated development environments? We were here, but in the meantime, we are here, okay? The IDEs allow you to do much, much more in the meantime, so you get lots of information. And what does this information allow you to do, essentially? To reflect. It allows you to reflect on what you do while you do it. And so in that sense, it's not anymore about the system itself, it's about all the information that revolves around the system. This goes from bug reports to development emails and chats and so on, interaction data in the IDE and so on. So you get lots of information. And with that information, you can do something. Another thing which is important about that information is that most of it is actually unstructured. It's not structured. What do I mean by that? If you look at this, for example, this is a bug report. You have a structured part, okay, which is up here. And then you have an unstructured part, which is down here. And the unstructured part, as a matter of fact, is much more interesting because that's humans talking to each other. Or you have an email, so you have the structured part up here that you can easily parse and use. And then you have the unstructured part, which is here. Very, very interesting. Now, what can you do with that? Well, this goes too far, but through the use of advanced technologies like island parsing, okay, and information retrieval approaches, what you can do is to have the computer understand that all this, as a matter of fact, is diverse types of information. And then you can use those diverse types of information for certain purposes. This is something that you as humans don't really know how to not do, but for machines it's really difficult, okay? This is the work of another PhD student of mine. And this then all leads to another field which has come up in the past couple of years. That's the recommender systems. So recommender systems for software engineering. The point is essentially that developers don't develop alone anymore, okay? That they often work with people. But the problem is that when people are not around, how can you get help from outside? Well, the point is that the web is out there. you have all this information that you can somehow collect and route into recommender systems. So on the example of the emails, for example, we wrote a recommender called Remail for Eclipse again. This allows you to register to mailing lists that pertain to your system, and it will recommend emails to you that are worth being read while you program. There's lots of recommenders out there, but they all have two problems. The first one is that the recommendations are not spontaneous. This means you always have to ask, okay? And the second one is that they are not self-confident. So if you go back to the pair programming thing, it's like having someone sitting close to you, and that person normally says only reasonable things and doesn't talk the whole time, okay? Now, this thing is that often these recommenders talk either the whole time or are completely silent, and then you have to prod them, okay, like, can you help me? And the other thing is that whenever they say something, they say it whether it's stupid or not. They will just say it. My vision goes more into something like, you know, the good old Alfred of Batman. That Batman without Alfred would be nothing, okay? The guy is always there when he needs him. And this will then eventually go into something like intelligent or immersive development environments. Now, how can you do that? I'll just show you one very recent example, a work that will present 2 weeks from now at IDE in India. It's called Prompter. How does that work? I guess most of you are aware of Stack Overflow, right? This is a live movie of Prompter. So here you have a guy who is starting to develop an echo server in Eclipse. While he writes the source code, Prompter is looking at the source code that you are writing, going to Stack Overflow, mining Stack Overflow, and then starts to shoot suggestions, given a certain confidence level. In this case, the developer says, OK, I'll go and check out that one. He goes over here. This is now the Stack Overflow discussion. And he can start to actually copy-paste and actually drag and drop pieces of source code from Stack Overflow directly into the environment, OK? Now, as you will see, when the guy is done, he will try it out. This will happen now. Now he runs it. So then he does a telnet and then does some echo stuff. And as you see, there is no echo on the left side, OK? So this kind of works, but it doesn't work. So then he clicks on another discussion, and then that discussion will point him to the fact that he forgot an instruction, which is this one here, that you should try an out flush, OK? So he copy-pastes the out flush in there, and then compiles the whole thing again, and it runs, OK? I hope you think this is cool. Now, my idea there is inspired by a science fiction book. I like science fiction a lot. The book is called Snow Crash, in case you are aware of that. In the book, they present a guy called the librarian. It's a demon, and it's just a piece of software who can navigate vast expanses of information and then collect them and present them to the person who needs the information. So this is my vision. Now, what happened with Prompter? Did it work or not? Of course, we had to do another experiment. OK, it's academia after all. The results are pretty evident, I would say. The people were actually much better at doing tasks, especially when they have to develop something from scratch. Then Prompter is really useful, OK? Now, you might say that, well, what's the difference between something like this and Google, OK? Why don't you just Google for the damn information? Now, you know, there's a difference between a librarian and Google, and I'll put it like this. This is what librarians do, OK? They do lots of stuff. This is what Google does, OK? They do very little stuff, OK? So, no, you can't rely on Google. You need something which is much more intelligent, OK? OK, my time is basically up. It's time to close the circle. Now, did I manage? I would have loved to come here and then give you some dramatic demonstration of how I killed a god. I'm sorry to say it's not there yet, OK? It's going there slowly. But I guess that I'm more somewhere at this stage, OK? Now I've identified the god. One big problem really is that developers don't change, OK? Developers, while they are on the one hand exposed to really modern technology, and they are at the forefront of humanity in that sense, are the most conservative people I've ever seen on this damn planet, okay? Because if once you are a VI fetishist, you will never get away from VI. And this is absurd. What is the solution? I'll just wait until everybody dies, okay? And then the next generations will get it. So I cannot end on a high note. But with respect to change, I am actually very positive. I'd like to leave you with one of my favorite short stories. It's from Kafka, and it's about change. And this is the end of my keynote. Thank you for the patience. Das sind 2 Gigabytes. Normalerweise tue ich das Zeug auf Slideshare, aber Slideshare hat jetzt eine 20 Megabyte Limite, das ist nicht mehr für mich. Aber ich werde sie auf meine Webseite tun.
Michele, ganz herzlichen Dank. War sehr interessant für mich. Ich freue mich, dass du immer noch auf dem alten Weg bist. Ich denke, du wirst unser Stammgast werden.
Okay, vielen Dank.